Hello everybody, it's Mike Levin on Tuesday, March 16th, 2021, and today I thought I would give you a little poem that gives you the main gist of my current work leading up till now and the subject of this video. So everything's command line tools and everything has args. Everything has keyval rules and space from hard drive carves. Everything's got custom types whose value will quadruple when from collections you import the factory class named tuple. And to go on with this nonsense, an ode to the named tuple, for record entries, return values, or arguments made great, DB keys that really please you just instantiate. The meta class to which you pass a name and splittable string, from which you'll get not dog but pet you access through pet.name. Give it a pat before you splat your instance into gunk, accessible as dict in full from inside pet fed funk. So there you go. That's good OO. I once felt was forbidden, and now at last don't feel subclassed. Complexities well hidden. And so when last we left off, my basic sort of scaffolding of every project got down to getting some credentials for interacting with Google services. I don't even need to run any of that for this next step, which is from collections, import named tuple. All right. So now you've got something called a named tuple. And it's a very well internally documented named tuple. I'll just point out the good design of this thing right off the bat. It tells you it is a function. That's the type that goes in the first location. So the thing that you're looking at, its type is a function. It's found in collections.namedTuple of the standard library. And then you've got a API definition here. The first position is type name. So we're making a data type. And the next one is field names as a single entry, which is interesting because it's a plural thing. You're providing field names. And then you have this splat character here, which means you can take in any number of non-key value arguments, item. So a list goes there, really, which makes sense when you see what it's for. Now, these other three args I don't use very much, so I'm going to ignore them. Now, if you were to check what the type of that thing is, you've checked type, named tuple, it should back up what we learned up here. It is, in fact, of a type function. So you're sitting on top of a function. So functions are made to be called, right? So how do you call a function? You just put the parentheses after it. Well, you get an error because the first two parameters are required. So what do we put? Oh, I don't know. It looks like it's a type name. So we will make, of course, foo. Up, 2 arguments required, not just 1. It seems like it can be a single string. So I'll just make my first item in the string. Hey, it took that. Look. So we've got a function named foo in our main, which is this .ipynb file. Normally a .py file, but that's the same main as if name equals main, then run. So we're sitting on top of a function called foo. What, are you saying that's a function? Can we do stuff with it? Can you call that in turn? No. But there are things in it. Oh, command line completion doesn't. Oh, there it popped up. Look. There's a first in it. well, that first is the same word we use there. Is that the same thing? Well, let me select it and run that cell. Well, it's something, right? It didn't throw an error. So it turns out that that's something that you can set a value to, but it sort of poofs in memory. How do you even access it? Because you're recreating this all the time. So that doesn't really make a lot of sense to do, but this much does make sense. Now, to the normal example you get of a named tuple at this point is you say lowercase foo equals that. And so you'll notice a pattern that sort of gets set forth. An uppercase version gets used there. Oh, in fact, let me fix my mistake. An uppercase version gets used here too, because we're using this function to create a class. That is still a class that we instantiate from. So if we were to type foo on a line by itself, it's the same as if we ran this portion here. It does the exact same thing. So what we've done is we've made a parameter here. So if we were to put bar in here as a position dependent parameter, you'll see it like that. Now we also could do this, because when you have named parameters, you can use the name there. That's how you get out of orderness of parameters. Well, what do you mean out of orderness? There's only the first parameter. Well, let's say we were also to give it a second parameter. Now, if we do that, missing argument second, first equals bar, second equals, well, we already used bar of foo bar, so I guess we got to move on to spam. Okay, so there you have a instance of calling the foo object, setting some of the values, right? But still you have this same problem that it's just sort of floating there in memory. What good is it unless you carry it around? And this is where we now use the lowercase version of it. And so now we're sitting on an independent case of foo, which is a complete bundled up package of properties. And it has some interesting things here, like instead of accessing its internals with the square brackets and all the extra typing of this, in fact, it won't even work. If I try to do it, it won't work, because dot notation is automatically used. So we have foo dot first, we have foo dot second, and there you have it. So I talk a little bit about splatting arguments. Just to make this complete, let's give it a third, first, second, third. And I could show you that this is shorthand notation, because you remember when we looked at the function definition, we're field stuffing. And internally, you can bet there's some sort of string, eval, whatever going on, a split function, breaking that up when you provide it in sort of a parsable format. Otherwise, you could feed it a list. So this first, second, third that I'm doing right there could just as well be provided as first, second, third, right? So that will have the same result. This will create an error because we now have a third parameter. Eggs equals, no, yeah, it's third equals eggs, spam and eggs, plural. Okay, and now there's a third. Okay, so I've demonstrated that this can be fed in either this way as a proper Python list, which is taking advantage of that splat there. That's the first place we're going to see splat notation on this video. I'm going to show you another. But why not use this much more readable shorthand notation when it has exactly the same result, right? Okay. So the splat of which you speak, say we were to make a function def I've done, so it's just an arbitrary thing that we're going to feed a foo. What do you feed a foo to? It's going to be a foo eater. And that will take in, let's see, I can either feed it in as a series of values. By the way, when I did this foo first equal, another way of stating that, it must be known, is that foo can be set equal to foo bar spam eggs. You don't have to provide those handles there, and you'll get the same thing out because it has a position dependency, because it is, in the end, it's a tuple. If we did a type on foo, you will see it's that, but I guess if we looked at subtypes or whatever, we could see that it's actually a version of a tuple data object. So I don't like that showing as much as the actual value. Okay, so we're making a foo eater function that takes in some args. See how I have an asterisk there? And we'll just print args. Okay, so we can take foo eater, and you would think you could just feed it the foo object because it's a foo eater, right? But you would find out that it has this, it just feeds it out as exactly the way it came in as the named tuple as it is. But if you wanted to populate the arguments in the order they occurred, you simply put an asterisk feeding it in, and now you've got bar in the first argument location as if it were a function that supported 3 positional arguments, bar, spam, and eggs. You've got there. Now, if I were to use the other convention here, and if you wanted it as a dictionary, accessible as a dictionary, see, this is what's available inside the function. You have accessible to you a variable named args, which is a tuple containing all 3 values fed in. If you wanted a dictionary there, so it preserved those file handles, because you've got, it's not file handles, but preserve the parameter names, the argument names, the keyworded arguments, you would use the convention. You don't really have to change it to that, but you would change that word to kwargs so that when you look at it, you know what you're looking at. You'd put 2 asterisks there, and now you can print kwargs, and what comes out is an error. It takes 0 positional arguments, but 3 were given. This class has the built-in asdict internal thing. Those underscores sometimes mean you don't use it, but it's there, and it'll turn foo into a dictionary and make it kwarg splatable. So we take that asdict method and we just stick it in here where we feed the function foo. That's dot underscore asdict. And we still may need to splat it into the function with a double asterisk. And there we go. That's what I'm looking for. So to make it clear, we'll make a foo splat eater. Yeah, so we just want 2 of these. We copy that, we paste it, and we make version 1 and version 2. Make it real easy. If I can click straight. And this one will take the first convention, which is just args, and just print back out the args it received. And this will use the other convention, which is double splat keyword args, and just print that out. And so we'll need 2 of these, one that calls foo eater 1, and we'll copy paste that. And the second one calls foo eater 2, and we'll see what we get. We're going to have to change things a little bit. That's a single asterisk, and it doesn't need the asdict. wouldn't hurt to get the functions in memory. And there, that's pretty much it. This is the end of this presentation because I took it all the way from just sort of putzing around and discovering what a named tuple is after the import, seeing that it's a factory class. They don't really spell it out, but with the factory class, you can create this data type. We created a foo data type. This is where the data type got its name, and then we create the sort of cookie cutter master instance matching the name, so it's all lined up. That way, from that time forward, you can refer to foo like this and stamp out instances, and you can also do it in the shorthand notation, and it's I guess commonly done to use a lowercase of it, and that way you have an instance of the data type class that you made using a master, bad terminology, not politically correct, a meta class, I guess, subclassing. I got to get my object orientedness correct. I demonstrated to you how you could feed it in using a list or a parsable string, the parsable string being the more convenient shorthand notation, how you use the dot names here of the arguments to get the values out, and how you can use those to feed in as values of functions. We're feeding that same foo that we used up here with these values into these two respective functions, and you can see how it becomes available inside the function as a non-named tuple in the first place, just a regular tuple with those three fixed locations. So your functions don't have to be named tuple aware. It sort of becomes a tuple as it drops in through that direction. And if it drops in through this other direction, it becomes a dictionary whose, name value pairs exactly match the named tuple instance that you have up here. All you do is you kind of lose this original object name, but it's kind of arbitrary, so it doesn't matter. For generic use purposes, this is complete. This is showing you how the common import in almost every project, like I showed how in every project there's pickling and logging and figlet and arg parsing. There is too, in my book, in my assessment, in every project from collections, import named tuple. So that goes up here as well. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.